Hey guys, today we are going to talk about functions. In relations, you have two different kinds of numbers. You have two sets of numbers. One is known as domain. Domain, you also can call the domain as object. And normally we will use a mathematical notation x to represent it. And another set of a number is known as codomain. And it has another name known as image. We normally use the mathematical notation f bracket x, that means the function in terms of variable x or y, to represent it. And the set of image is known as range. So this is the definitions of the range. There are four types of relations inside of functions. The first one is one-to-one. The second one is one-to-many. And the third one, many to one, and the last one, the fourth one, many to many. The most simple one is the one-to-one relations inside the functions. So the example of the one-to-one inside the relations of the function is, for example, y equals to x, or you can write in this form, fx equals to x. The diagram is like this. You have a y-axis, you have an x-axis. It's a straight line because I don't have a ruler. So you have a 1, 2, 3, here also 1, 2, 3. So each of the domain, or we call as a x value, is respected to the y value. So if you have 2, then you 2, and 3, 3. That means actually is f 2 inside the function equals to 2 for these functions. So if you write into a set of numbers, so it will be like this: 1, 1, 2, 2, and 3, 3. So for one-to-one function, each value of x is respected to the value of y. You only have one connections. You cannot have more than one in terms of x and y. If not, it will become one-to-many, many-to-one, or many-to-many relations inside the functions. So if you draw the mapping diagram, it should be like this. So this is a 2 mapping diagram. This is a 2 mapping diagram. And the left hand side is a domain, also known as x. The right hand side is a codomain image, known as fx or y. So you connect here. So you can see just only got one connection only. Either x, the object, or the y, the codomain, or we call the image. So this is the 1-to-1. This is the 1-to-1 relation. Okay, the next slide, I mean the next thing I will talk is the many one-to-many relations inside the functions. So the most obvious example is the quadratic equations. Let's talk about the second type of relations inside the functions, known as one-to-many relations. One of the obvious example of this one-to-many relation is the function of y squared equals to x, or you can write in this way. We seldom write in this way, but you can write in this way: fx squared equals to x. So the diagram of these relations inside the function is look like this. You have a y-axis here, then you have a x-axis here. So this is the x-axis, and this is the parabolic function, the parabolic shape that rotates from the y-axis by 90 degrees. So you have 1, then you have 4 here, so what you see is each of the value of object is respected to two value of image. That means each of the x value have a corresponding relations with two values of y. And you can write this function into a set of number by simplify this. Simplify y squared equals to x, then become y equals to plus minus square root x. So when you put the number inside, let's say you have we still count the 0. So let's say you have 0, then x equals to 0, then y equals to 0 also. And when you have x equals to 4, then y equals to plus and minus 2. And when you have x equals to 1, then you have y equals to plus and minus 1 after you square it. So the set of number can be written in this way: 0, 0. So start with the smallest one. Start with in the way of ascending. Start with in ascending way. So 1 minus 1, 1, 1, and then you have 4. Then you have minus 2, and then 4, 2. And when you try to draw the mapping diagram, how's the mapping diagram look like? The mapping diagram is look in this way. So you have x here, the object, and then you have y here, the image, also known as fx. Okay, so just put in all the number. Let's say you have x equals 0, 1, 4, 0, 1, 4. Then for y, maybe we can do in the more order way. Write the number in this in this map in an order way. So 2, 1, 0, minus 1, minus 2. So of course 0 you connect to 0, and then 1 you can connect to 1 here, minus 1 here. Okay, so for 4, 2, you connect to here. So this is the mapping diagram for one of the example of one-to-many relations inside the functions. So 1 here, when you're talking about 1, you see 1 connections. Then also 1 connections connect to 2. 2 numbers, 1 to many. So this is the end of the describing how is the one of the one-to-many functions look like. Third type of relation is the I want to show you is the many to one relation. For the function that has many to one relations, we have a simple example known as y equals to x squared. It's a quadratic function, or you can write in this way, fx equals to x squared. If we want to draw the diagram, the graph for this fx equals to x squared, this is very simple. This is an obvious quadratic equation. Okay, this is 0, and then 1, 4, then we have 1 here and minus 1. If we want to write this set, if we want to write a set number to represent this function, then it will be like this. You have x and y. Let's say 0, 0. You have a 0 number here. So okay, you substitute 1 inside 1, then you get 1. Then you substitute minus 1, then you also get 1. You substitute minus 2, you get 4. Then the last one, you substitute 2, you get 4 also. So this is the many to one function from the x domain. So to draw the mapping diagram, you can draw like this. This is a 2 mapping diagram. You will have 2 here, 1, 0, minus 1, minus 2, and then of course descending order, 4, 1. So many from x. So you don't draw arrow here, sorry, you put point here. So this is x, this is fx or y, and then from 1, okay, so this is done for the many to one functions. For the set number, you write in this way. So if you have a 3 here, of course later you if you put 3, 4, 5, minus 3, minus 4, minus 5, then you will have the y equals to 9, 16. So 2 more than 1, that means many relate to one function. Many to one function. Okay, the last relations inside the functions, the fourth one is the many to many relation. One of the typical example is the circle. The circle have a function or equation equals to x squared plus y squared equals to r squared. The r here is a radius of the circle, and then of course you can write in this way, but we seldom write it because it's a bit strange. You write in this way, and then the diagram of this equation. Let's say you have this is the y-axis, this is the x-axis. Let's say you have a circle equals to radius 1 cm. So you have 1 here, minus 1 here, minus 1 here, 1 here. So of course you link it together. The circle actually is a bit not regular, but assume it's a circle. So of course this is the center of the origin. Each of the coordinate respect to the center of origin is 1 cm, represent the radius of the circle. And then you have a coordinate here is equals to so here you have you have 0 1, and then here you have 1 0, here you have 0 minus 1, of course here you have minus 1 0, and if you try to write the set of the circle in these numbers, so you will see it's a 0 0, and then 0 1, 0 minus 1, and 1 0, 5 set of numbers, minus 1 0. And if you try to draw the mapping diagram for this many to many relations for the functions, this is how you're going to draw it. So this is x domain, this is y codomain of fx, because it's an image object. And okay, you will see here 1 0 minus 1, 1 0 minus 1. So of course 0 is linked to 0. Sorry, always don't use the arrow, use the point here. So use 0 linked to 1. So for you have for 1 0, and then here, but then you can see 1 to many, many to 1. So this is the how we're going to draw so-called the many to many functions. That means 0 you have 3 here, the 0 here you also have 3. So this is it. In functions, you also will learn 2 types of the simple functions. The first type is composite function. Composite function involve combining of 2 or more functions. Combining 2 or more function. And for an example, you will see g f x. That means a composite function consists of function of f and g, or that means times itself. The composite function consists of 2 functions of g. Another one is inverse function. So inverse function is a function that mapping image to object. For example, let's say f negative 1 or g negative 1, h negative 1 function of x. Sorry. The composite functions that have a mapping diagram actually is like this. Let's say you have a function of f g x. So you have a, b, the element inside the mapping diagram, a, b, c, d, e, f. So this is f, this is g. That means this mapping diagram is showing the function of f gx. For the inverse function, that means the function that mapping image to object, mapping the codomain to domain, then you have, this is the forward function. Forward function. That means if this is the function of f, then of course xy, xy, x1, y1. That means if it's come another way around, this is the backward function, mapping image to object. So this is a f minus 1. Press like, share and subscribe button if you like this video.